Hello, I'd like to share with you all of the parts that are designed to be 3D printed on the Scuttle robot and how they are designed to be oriented in the 3D printer. So right now I have a layout here in Simplify 3D, basically just demonstrating each of the parts with its bottom side fixed to the plate, and I will mention the two parts that will include supports, but all of the majority are not intended to have any supports. Here in the front, this is the motor driver bracket on the robot. It looks like this. It holds the circuit board that drives the motors. And you'll notice that all the features that are overhanging have an inclination higher than 45 degrees. In ABS on a FlashForge Dreamer, these have printed fine. And I'm sure if we step up to a higher quality printer, they should do even better. The next two parts are the case and the cover for the battery holder. On the robot, they look like this. The cover is actually hidden right now, but you can see the case has one flat side here, and that's meant to go facing down, and then so the top side is on the right hand here, and all of the features overhanging once again are inclined higher than 45 degrees. I think we can go ahead and unhide the two covers that I have here. Battery pack, lid, shell components. So there you have the lid. It's going to be printed in the opposite direction with this right hand side facing down. Here if we move to the BeagleBoard PCB bracket, we have the cover here, shell components. So this part is printed with this face down, and the cover is printed with this face down. And you'll notice once again, everything is designed to be growing in the Z direction, but not with any abrupt overhangs in the Z direction. We'll come back to Simplify and I'll show you how it looks. Here's the BeagleBoard bracket. Here's the BeagleBoard bracket lid. And these have all been tested, once again, in ABS with a layer thickness of 0.3 millimeters. We can go finer than that. I don't recommend going coarser than that, but it all should come out fine on a Dremel machine, on a Dreamer, or on a high fidelity machine, or on a Ultimaker machine, certainly. This bracket here is for the ultrasonic sensor on the robot. It's in the front. It's just holding this circuit board here, and it has the female dovetail feature to go to the universal bracket. These two are the two spacers in the drivetrain assembly that coupled to the shaft, and you'll notice only one of them has a chamfer. The chamfer is important, and it's important for fitment, and it needs to be pointed up. Otherwise, it might have a little bit of slop on this angle. This one can be printed in either direction. Oops. In the drivetrain assembly, this is the spacer that has no chamfer, and then in here we have the spacer that has a chamfer. At the risk of crashing the computer, I'll try and make a cross section to show how it's implemented. So this spacer here is contacting the wheel bearing, and it needs to contact just the inner race of the bearing because this race remains static while this race is rotating. And then as you can see here, there's no chamfer required. Neither of these have a tight tolerance to touch the shaft. They're just a slip fit with respect to the shaft. Okay, this bracket here is for the compass sensor. It fits with the female, it has a female dovetail feature on the robot. In this case, it's in the front. In reality, it may be placed in another location. And this face here is intended to be the bottom face, once again printed with no supports. These two pulleys, they do have a small overhang. You can see that here, but we've printed them in the past on 2 different machines with no supports and no problems. This underside of this face here can get a little bit rough, but it doesn't interfere with the belt because the belt is not very wide. There's actually some gap. So, sorry I keep clicking the wrong button because I'm used to the SolidWorks controls, and the Simplify controls are different. So this is the motor pulley, and this is the wheel pulley. Not too much else to say for these other than they, once again, were designed to be printed with no supports. This is the camera bracket. This part here is designed to let the wire slip in from behind, and we can see the bracket here on the robot. In this case, it's upside down. It could also be mounted right side up or sideways. And then this is the face that's intended to print flat. These two brackets here are identical, although they're used slightly differently. It's the right hand and left hand encoder bracket with these arrows indicating the screw holes that we use if you're putting it on the right side of the robot. When you put it on the left side of the robot, you use these 2 holes, and it offsets the circuit board just slightly. The other 2 holes, these are through holes for screws with clearance to the threads. And all this bracket does is hold the encoder circuit board near the pulley. So this is the bracket, these are the 2 through holes, and then we have components. We have 2 holes being used on each side for screws to mount the PCB. Alright, finally we have the universal bracket right here and the rod holding bracket right here, and these ones have features that would not they're both fairly critical. In this case, we have this cross section here that needs to fit into our aluminum T-slot rails, so the accuracy needs to be nice. If it's printed in a different direction, then it could still come out, but then the tolerance on this profile here is loosened if we print in another direction. So this is the intended direction, but we do need supports supporting this face here. This face comes out a little bit rough, which makes it a tighter grasp on the rod, but we've basically designed to increase this radius and this gap here so that we can still hand fit the rod and clip it in the direction from right to left. It needs to be it needs to have still a tight tolerance because that clip is going to hold a little bit of weight of the circuit boards and the battery. Then we have the universal dovetail, which the critical feature, one of them is here. This profile needs to be maintained, so that's in the XY plane. And then the other feature is this here with a profile here that needs to be maintained, including this curve. This curve here allows us, and this curve here allows us to put the bracket into the T-slot and then rotate it to snap it in. So this is the universal bracket. Hide component. It gets inserted into the T-slot frame, and then it gets rotated, and then it has a friction fitment that prevents it from rotating or sliding after that. These two parts do well on a high fidelity printer, but it's very likely that they will succeed if we just use the desktop printer and print them carefully. So in this case, I always print this part with supports on the bottom edge here and this bottom edge here, and I make the support structures closely spaced, so every 1.5 millimeters at least we want a row of supports to maintain that shape basically. And I deleted the other part that I was just referring to, but it's essentially the same situation. So that should be all the parts.